Hi guys, welcome to my channel. I hope everyone is good. Today we can see here high density challenges and overcome. So first of all, we want to see what are the challenges will be there in the high density. Density and area optimization, power and signal integrity, timing closure, parasitic impacts, electromigrations. The first challenge is high density and area optimization. So what are the challenge will be when we are choosing a high density cell, the first major problem is area only. So how we can avoid this kind of area issues? So some techniques will be there to avoid this kind of density and area optimization. What are the techniques? First is the aggressive cell placement. Second is tight routing. The third is that efficient use of routing resources. Fourth is the minimize the required area. So fifth is that we should use that synthesis tool. We should know about that all the layout synthesis tool. Next is the optimize the placement. So area. And next is the selector transistor size for area optimizations. The next challenge is power and signal integrity challenge. When we are choose the high density circuits, the power consumption going to increase. So when we are select the power getting techniques, we can switch up the particular circuit. So in this method to help to reduce the power consumption. Next is integrity. So when we are the neighboring signals, it's creating some kind of signal integrity issues or coupling noises. So when we are choosing the shielding process, shielding techniques, we can avoid this kind of integrity issues. And the next challenge is timing closure. When we choosing that high density circuits, the parasitic impact is going to increase. Okay, this parasitic impact affect the times like delay time. So increase the delay time. So how we can avoid this kind of timing issues? So when we are choosing that clock gating techniques, so we can switch off unwanted clocks. This kind of techniques help to avoid the unwanted noises and interference, so we can improve that timing issues. The next challenge is parasitic extraction. Already I told you, when you are choosing that high density cell, the parasitic effects going to increase. So just what are the if we increase the parasitic effects, it's not only affect the timing, it's affect that power and performance area all the ways. So we should reduce the parasitic effect. So how we can avoid this kind of parasitic effect? When we are choosing that optimized layout technique optimization techniques, we can avoid this kind of parasitic extractions. So first of all, we want to know what are the location, how much parasitics is impact. So we want to analyze, correct? So when we should check with extraction tool, use the extraction tool, and we can check this parasitic extractions too. We should avoid this kind of extractions. The next challenge is electromigration. When we are choosing the high density layout design, so that current densities also increase. So when we are choosing the current density increase, it's possible to create a electromigration effect. So we should avoid this kind of electromigration. So when we prefer for high width net and proper widths, so we can avoid this kind of electromigration.